Good afternoon. Now we will see day 5, part 1. So we have day 5, part 1, that is on torsion. So we will see day 5 problems, that is of torsion. We have 3 problems on this torsion. So we have first, the solid shaft has to transmit 75 kilowatt at 200 rpm, taking allowable shear 70 and find suitable diameter, exceeds the mean by 30%. Was asked in IS 2019. So we have simple formula for power. P is equal to 2 pi n T average, and as it is given RPM, so upon 60. Now P is given 75 into 10 raised to 3, which is equal to 2 pi n is given 200 upon 60 into T average. Sorry, into 60 upon 60 into T average. So we have, from this we will get value of T average. Just a minute. So we have 2 pi n is 200 upon 60 into T average. And from this we will get value of, therefore, T average, that is equal to, I got this value 3.58 into 10 raised to 3, but we know unit is Newton meter. So we have 3.58 into 10 raised to 6 Newton millimeter. Then find T max, which will be 1.3 into 3 T average. And we have this will be 1.3 into 3.58 into 10 raised to 6. Value is 4.66 into 10 raised to 6 Newton millimeter. We have to find a diameter. So now it is solid shaft. So we know T is equal to pi by 16 d cube into tau. Tau is given 17. So we have 4.66 into 10 raised to 6, which is equal to pi by 16 d cube into 70. And from this we will get d cube, this is equal to 4.66 into 10 raised to 6 into 16 divided by pi into 70. And if you calculate this, d we got 69.73 millimeters. Then we have second, a solid shaft of 200 mm diameter has the same cross-section area that of hollow shaft of the same material with external diameter as 250. And we have to find a ratio of power transmitted. So first, area of solid shaft equal to area of hollow shaft. Now we have pi by 4 into diameter of solid shaft square equal to pi by 4 into d, that is external diameter of hollow shaft square minus internal diameter of hollow shaft square. Now ds is given 200 square, which is equal to 250 square minus d square. And from this we will get d square, that is equal to 250 square minus 200 square. We have taken d square on left and 200 square on right. And from this we will get value of d, and that we got as 150 millimeters. Then we have power transmitted by solid shaft upon power transmitted by hollow shaft equal to 2 pi n T average upon 2 pi n T average. So this average is of hollow, this average is of solid. So 2 pi n gets cancelled. Now what is T average for hollow solid shaft? So we have pi by 16 d cube into tau. And what is for solid shaft? Sorry, hollow shaft, pi by 16 into d4 minus d4 upon d into tau. Tau gets cancelled, pi by 16 gets cancelled. And we have PS upon PH, which is equal to, this is ds, solid we have mentioned as ds. So we have ds cube into capital D divided by d4 minus d4. Substitute the values. So we have PS upon PH, and that is equal to 200 cube into external diameter is 250 divided by 250 to the power 4 minus 150 to the power 4. And from this we will get the relation between PS and PH. I got this value as 0.87. And then we have last problem on this. A composite shaft shall consist of a copper rod. So we have to actually use concept that is of indeterminate. So we have this will be hollow shaft, and inside this we have actually solid shaft. So we are in this mesh. So we have this will be hollow shaft. Now as this is composite, so whatever deformation that is of hollow shaft should have same for solid shaft. And inside portion, just I will make it with another color. So this is solid shaft. So this solid is of 50. And then you can see 5 mm thickness. So for hollow, we have 50 mm internal diameter as it is. 5 mm thickness, so this goes to 60. Now we have theta same. Theta of solid should be equal to theta of hollow. Now what is formula? T by J, that is equal to G theta by L. And from this we will get theta equal to TL upon GJ. So we will have T of solid, L we have same, divided by G of solid. Instead of this, I will mention it as copper. So we have theta copper and theta steel. So will not be any confusion of this. So of copper and J of copper, which is equal to T of steel, L we have same, divided by G of steel, J of steel. L we have same, so gets cancelled. And now we will put the remaining values. We have TC divided by G for copper is 40 into 10 raised to 3. And J for copper we have pi by 64 into 50 to the power 4, which is equal to TS divided by, we have G 80 into 10 raised to 3, as it is hollow shaft. So we have pi by 64 into 60 to the power 4 minus 50 to the power 4. When I solve this, I got that is T S equal to 2.15 TC. So 2.15 TC, that is equal to TS. And then if we will put total, we know TC plus TS, this is given 1400 Newton meters. So now we will put TC plus 2.15 TS, and that is equal to 1400. And from this we will get TC equal to 444.44 Newton meter, and TS we have 955.56 Newton meter. And now we will solve this. So we have TC, this is solid shaft, equal to 444.44. It is Newton meter. Convert it into Newton millimeter, which is equal to pi by 16 d cube tau. And then we have 444.44 into 10 raised to 3 equal to pi by 16 d, we have 50 cube into tau, that I will mention as copper. And from this we will get tau of copper, that is equal to 18.11 Newton per mm square. And second we have T steel 955.56 into 10 raised to 3, which is equal to pi by 16 d into d4 minus d4 into tau of steel. And we have 955.56 into 10 raised to 3 equal to pi divided by 16 d, we have 60 in bracket 64 minus 54 into tau s. And from this we will get tau s, that is equal to, so I got this value, and that value is 43.52 Newton per mm square. So we have values of tau for steel and value of tau for copper. So this is about first part of day 5. Now we will stop here only. Remaining part we will see in the next video. Thank you.